Hello, welcome to the video of my electronic lab series. Still I'm talking about current source. In this video I want to show you one possible use of current source, although if you are watching you already know why do you need one. We can use current source, for example, to check our LED diodes, to check which current is needed for LED diodes to light when we design our electronic circuit. I have connected terminals for LED diode, and also I have connected my voltmeter. Here is a voltmeter. These terminals are in parallel with output terminals, so the voltage I measure here, it's the same as I have put my probes on the LED diode. So here is LED diode, and I will adjust some current through it. What can we see? I have reversed polarity, so that is positive. They are both of the same length, so I didn't immediately realize which one is plus. So we can check polarity, and also okay, now let's flow some current through it. You see how our LED diode lights, and the maximum light I achieve around 14 milliampere. So let's say it lights between 10 and 14 milliampere, and at the same time the voltage across diode is around 2 volts. I will get some other, for example this one. Here is everything clear. Here is longer terminal and shorter. This diode lights already at 2 milliampere. Let's say at 4 milliampere it is already at maximum, so it is very different than this green big one. Then we'll try this white. Okay, so we do not need any resistor because we can regulate our current here. We do not need a resistor to limit the current because all of this is done by our current source. You see, less than 1 milliamp, it already lights very bright. So we need maximum 2 milliampere for this LED diode, and it is very bright. Or maybe this one integrated. Let's check one. We will also, okay, works. So it lights at around 5 milliampere. So with the help, and also always we can measure the voltage, so it's always around 2 volts. So with the help of current source, it's very simple to check our LED diodes, to determine polarity and to determine the current which need to flow through the diode. How will you design circuit with a LED diode? So just very short introduction. So now when we have determined for the first one we had 10 milliampere, for the second one 4 milliampere, for the third one 1 milliampere. And all of them have around 2 volts voltage drop. Let's say that we need a diode in a circuit, so it's LED diode, and that our supply is 8 volt. Okay. How will we determine this resistor? It's very simple. The voltage difference, since here is 2 volt, the voltage difference is 5 minus 2. That is voltage on our LED diode. We have 3 volt. And we will determine resistance as voltage. Here is the current needed. So for this diode, the needed resistance is 3 volt, that's 10 milliampere. It's 300 ohm. For this diode, the needed resistor is 3 volts, plus 4 milliamp, is around Okay, 750 ohm, and for this diode we need 3 volts 1 milliamp. It's 3 kilo ohm. So with the help of our current regulated current source, we have very simple determined the characteristics of our LED diodes. We have determined polarity, current needed for desired brightness, and then we can very simple calculate resistance needed to put this diode in some circuit. Okay, thank you for watching and stay tuned.